Welcome to the Square Academy. I am Siddharth. I am your physics teacher. Wait, in our last class, we have discussed about what? We have discussed about reflection and refraction of light. Today, we are going to start a new chapter. This is called chapter 12, and it is called electricity. So, first of all, what is electricity? So, before starting the electricity, we have some lots of various terms are there. So, what are the various terms? First term is called charge. Charge. So what is charge? Charge is the what? It is the intrinsic property of the matter. We have already discussed. So what is intrinsic property? Charge will be called as two types of charges reproduced. One is called positive charge and another one is called negative charge. And this charge we can denote it by capital letter Q or small q. You can denote both way, capital Q or small q. Okay, the positive charge and negative charge. So now SI unit of charge is what? SI unit is coulomb. This is called C. So SI unit of charge is called coulomb. There are two types of charge. One is called positive charge and another one is called negative charge. This positive charge is called, we can represent as proton, and negative charge is called electron. Positive charge is called E plus. Positive charge we can denote as E plus, or negative charge we can E minus. So this is the main conception about the charge. So charge is the intrinsic property of the matter. The SI unit of charge is called coulomb. There are two types of charge. One is called positive charge and another one is called negative charge. Positive charge is called proton, or you can denote as E plus, and negative charge is called electron or E minus. So this is about the charge. So now what is electron? Proton. So electron has one value is there. So this is what is the value of one electron or proton? One electron or proton, this value is what? 1.6 into 10 to the power minus 19 coulomb. This is very important. So 1.6 into 10 to the power minus 19 coulomb. So this is all about what? One charge value of one charge. Okay, so now this is all about charge. So charge is the intrinsic property of the matter, coulomb, positive, negative, and this is called E plus or E minus is called 1.6 into 10 to the power minus 19 coulomb. So next one, some properties of charge. Some properties of charge is there. So next some properties of charge. There are different types of properties of charge. So charge has some properties. So there are various types of property. Number one is called attractive property. Attractive property. Number two is called repulsive property. So there are two types of property. One is called attractive property and another one is called repulsive property. So attractive property means, suppose the two dissimilar charges attract each other. Two dissimilar charges means, suppose one positive charge and negative charge, they can nearby it, then this is called as what? They can attract each other. So this property is called as attractive property. Suppose one is called one positive charge and another here negative charge we can place here, they can attract each other. So that's why this is called attractive property. Attractive property. Okay. So another repulsive property means similar charges repel each other. Suppose this is a positive charge and this is positive charge. They can repel each other. Positive charge and positive charge, or negative and negative, they can repel each other. So that's why it is called as repulsive property. Repulsive property. Okay. So attractive property means dissimilar charges attract each other and similar charges repel each other. So there are two types of main properties, attractive and repulsive property. Now another one, this is a basic property. Another one is called as basic properties. So this is very important. Another one is called basic properties. So there are three basic properties are there. So number one is called additivity. Number two is called quantization. And number three is called conservation. There are three types of property, basic properties. What are they? Additivity, quantization and conservation. So they are very important. So now we can explain what additivity property, what is quantization and conservation. Okay, so next, what are the three basic properties are there? Okay, so first of all, what is additivity? Additivity. So what is additivity? Additivity means addition of charges. So how we can add the charges? Suppose one system is there. This is the one system. So there are various types of charges here accumulated here. Suppose we can consider countable number of charges there. Suppose this is suppose Q1 charge, this is Q2 charge, this is Q3 charge, this is Q4, Q5, suppose Q6, Q7 and Q8 number of 8 charges are present. So according to the additivity property, how we can add these charges? How we know that what is the total charge inside the system? So how we know that total charge we can call as add all the charges. Whether it may be positive charge or negative charge, we can add all the charges. So how? So this is Q1 plus Q2 plus Q3, Q4, Q5, Q6, Q7 and Q8. We can consider 8 charges, that's why we can add all the charges. Countable of charges, we can add it, then this is the additivity property. Okay, so next point is called quantization of charges. So next point is called quantization of electric charges. Next one is called quantization. Quantization. So what is a quantization? We can consider charge as one basic quanta. So what is the quantization of electric charges? Suppose we have tremendous amount of charges there. Suppose 10 crores, 100 crore charges there. What is the total number of charges? How we can calculate? We cannot apply the additivity property here. So how can we manage these things? So due to this, the quantization of charge is coming. So what is the quantization of electric charge? So according to this quantization of charge, now one formula is created. This formula is called Q equal to NE. So this is the main famous formula, Q is equal to NE. From this formula, we can also calculate tremendous number of charges inside any system of charges. Okay, so now Q is equal to NE. So what is Q? Q is equal to what? Total charge. Total charge. N is equal to what? Number of charge. E is equal to what? Electron value of 1 electron. So what is the value of 1 electron? 1.6 into 10 to the power minus 19 coulomb. So this is the constant value. It cannot be changed. Only change the value of Q and N. So from this formula we also calculate the number of charge. Q is equal to NE, N is equal to Q by E. So these are the two formulas arised here. Okay, so this is the call quantization of electric charge. Q is equal to NE and N is equal to Q by E, the same thing. Okay, so now quantization of charge is okay. So after that, next one is called conservation. So how charge can be conserved? So charge, what is the conservation of electric charge? So charge cannot be created. Already we have discussed that it is an intrinsic property of the matter. The charge cannot be created nor be destroyed. It can transfer from one point to one place to another place, or one wire to one point to another point. So this is called conservation of electric charges. So this is all about what? Properties of charges and basic properties of charge. This is very, very important for your exam point of view. So very, very conceptual questions are coming from these two conceptions. Okay. So next electric charge. Okay. Next another thing is there. So how we can consider it as a current. So what is there is a main charge. Now the chapter is the electric current. What is electric current? So current. So what is current? So current we can denote as capital letter I. Sometimes we can write as small letter I, but basically you have to write capital I. So what is current? Current means number of charges passing through one wire or one conductor per unit time is called electric current. Means number of charges, total number of charges flowing through unit time is called, per unit time is called electric current. So I is equal to, we can call as charge by time. So we can call as I is equal to charge mean we can call as Q by T. So this is the main basic formula for what? Current. Current means Q by T. So first of all we know current flowing through a per unit time. Charge flowing through a per unit time. Charge flowing through per unit time is called current. So charge flowing through per unit time is called current. So this is the main formula. Just I is equal to charge by time. So I is equal to Q by T. So we know according to the quantization, we know Q is equal to what? NE. Now this formula we can modify like that. I is equal to what? Q by T. Now this formula we can modify like that. I is equal to NE by T. So these are the three formulas associated with the current. Okay. So I is equal to Q by T or NE by T. So N means what? We have already discussed. N is the total number of charge. E value is always constant, 1.6 into 10 to the power minus 19 coulomb. So already we can write 1.6 into 10 to the power minus 19 coulomb. So T is the time, how many times we have to write here. Okay. So now, so electric current has some units are there. So SI unit. What is the SI unit of electric current first of all? So what is the SI unit of current? So I is equal to, we know that Q by T. Okay. So Q is the what? We already know that what is the charge unit? Charge unit is called coulomb. And T is called T SI unit, which time SI unit is called second. So coulomb per second is the SI unit of electric current in also represented as ampere or A. So now what is the SI unit of current? SI unit of current is called ampere or we can write it as A, or in case we can write AMP. Same meaning. Meaning is same. Ampere, A or AMP are the same meaning is same. That current SI unit of current is coulomb per second or Raman. In sometime in your exam it may be asked what is the SI unit of current in your MCQs, like they suppose coulomb per second. This is also correct. Okay. So SI unit of current is called what? Ampere or coulomb per second or AMP. Okay. So this is all about electric current. So now electric current has some electric current or electric circuit. Now next is called circuit. Circuit. So circuit is an arrangement of some conductors and some components in a network. It is one kind of network where we can connect some electrical devices are there. Basically this is solar conductors. This is called circuit. So circuit, suppose we can consider, so this is called what? One, suppose electric circuit is a what? Sometimes like that. So this is a one. Suppose this is one example of electric circuit. So this is battery, volt, current is flowing here. This is what? Bulb, and current is flowing like that. This is a one good example or simple example of electric circuit. Okay, this is a bulb and like that. Okay, so next to one question is arise. So how can you calculate the, first of all, a current? Suppose one question is there, a current of 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes. Find the amount of electric charge find the amount of electric charge that flows through the circuit. flows to the circuit, we can call it circuit. So how can we proceed this numerical? So first of all, a current of 0.5 ampere. So this is what? This is what? Electric current. 0.5 ampere. So now given, how we can proceed this numerical? Given current is equal to what? I is equal to what? 0.5 ampere. Drawn for a filament of electric bulb for 10 minutes. So this is what? 10 minutes is time. So now what is the time here? We can return time, or it's called small t, 10 minutes. So here time is 10 minutes, but our time is what? We can represent time in standard unit. So what is the time assistant in second? So now we can convert it 10 minutes into second. So how can we convert 10 minutes into second? 10 into 1 minute, how many seconds? 60 seconds. 10 into 60 is equal to 600 seconds is the time. So find the amount of charge, electric charge that flows through a circuit. So now we can calculate what? Charge. Charge means small q, we have to calculate. So what is the SI unit charge? So we know that from this we know that I is equal to what? Q by T. So Q is equal to what? I into T. So we have to calculate charge. I means what? 0.5 into T means what? 600 second. So after this multiplication we are getting what? 300 coulomb. Because coulomb is because the SI unit charge is called coulomb. That's why the answer is what? 300 coulomb. So any confusion? So ask me. Okay. So this is all about this numerical. Okay. So next is called Ohm's law. How we can represent the Ohm's law? And Ohm's. So this is the important thing for the Ohm's law. So what is Ohm's law? So first of all, Ohm's law is very, very important for electricity. Without Ohm's law, we cannot proceed further. So what is Ohm's law? Ohm is the one scientist who gave this law. Then what is the Ohm's law? Current flowing through a conductor is directly proportional to the what? Potential difference between two ends of the conductor. So before starting this Ohm's law, first of all we know that what is called potential difference. So now what is called potential difference? So this is very, very important. What is called potential difference? So potential difference is denoted by capital letter V. So what is potential difference? Okay. So potential difference means, suppose one charge is here, we can place positive charge here. So this positive charge we can call as Q. Okay. Another one positive charge from the infinity, we can place it here. This is the positive charge. It is called Q naught with a distance suppose R. Okay. So this is a positive charge. Another one charge is flowing through, carrying both from this what? Infinity in this position. Suppose here the position is suppose A and another position suppose is B. Okay. From carrying from that brought from this point P. So this is amount of work done will be produced. So here what? Positive charge and positive charge is what? Repulsion is positive. So this is the force acting in this direction because repulsion is produced. This is a force. This is a static charge. Okay. This is a fixed or static charge. This is a fixed. This is fixed. This is not no any force will be developed here. But in this is a state charge. So this charge is called as state charge. So here we have to place one charge Q naught at a point B. So what will happen? Due to the repulsion, what will happen? A force is developed here. And this force is called repulsive force. Okay. So now what is called potential difference? The amount of work done to bringing a unit positive charge from one point to another point against the electrostatic repulsion is called potential difference. Or there are two terms is there. One is called potential difference and another one is called electric potential. Another one is called electric potential. There are two terms same. There are two the means notation is same. One is called potential difference and another one is called electric potential. So how we can differentiate? So this is the infinity. Suppose amount of work done to bringing a unit positive charge from one point, okay, against the electrostatic repulsion, because repulsion is takes place against the electrostatic repulsion. This is called electric potential. Or amount of work done to bringing a unit positive charge from one point to another point against the electrostatic repulsion is called potential difference. Means if electric potential term is arise, then you have to introduce amount of work done to bringing a unit positive charge from infinity to that point. If a charge we can bring from infinity to that point against the electrostatic repulsion, this is called what? Electric potential. And what is potential difference? Amount of work done by bringing a unit positive charge from one point to another point. Suppose this is a positive charge is there, and this is the A point is there, positive charge from here to here. Suppose another positive charge for the B point, this is P point. So here to here, the amount of work done will be produced from here to here. This amount of work done, this amount of work done against this electrostatic force of repulsion is called potential difference. Okay, so what is the difference between electric potential and potential difference? Electric potential is the amount of work done to bringing a unit positive charge from infinity to that point against the electrostatic repulsion is called electric potential, or whenever a amount of work done to bringing unit positive charge from brought from one point to another point against the electrostatic repulsion is called potential difference. So this is all about the conception of potential difference. So now potential difference is equal to what? W by Q naught. This is the main formula for potential difference. So potential difference we can denote as V, work done by charge, is called what? Potential difference means what? V is equal to work done by charge. So this is the main formula for what? One formula for potential difference or electric potential. Okay, so now this is the potential difference or electric potential. So now what is the SI into potential difference? So first of all, what is the SI into potential difference? So now, so V is equal to what? W by Q naught, we know. So main formula is V is equal to W by Q naught. V is equal to W means what? Work done. So SI into work done means what? Joule. J. SI into work done, Joule. Charge is called Coulomb. So Joule per Coulomb is called volt. All B. So SI unit of potential difference or electric potential is called volt, or we can another way we can derive as Joule per Coulomb is called another unit of potential difference or electric potential. This is all about electric potential or potential difference. Okay, so now next very important topic is called, now we can explain Ohm's law. Now what is Ohm's law? So one scientist name is Ohm's, so he can give one law regarding the conductor whenever a current flowing through a conductor. So what is the Ohm's law? Ohm's law means whenever a current flowing through a conductor, suppose a current is flowing through a conductor. This is a conductor, current is flowing. How the current is flowing? We have to use some energy here. So what is the source of energy? We know source of energy is called battery or cell, dry cell or any kind of cell. So battery you can replace V. So current is equal to what? I current is flowing here. Okay. So whenever a current flowing through a conductor is directly proportional to the potential difference between two ends of the conductor. Means what? Current flowing through a conductor is directly proportional to the potential difference between two ends of the conductor. Means whenever current is increasing, automatically potential difference also increasing. Means potential difference increasing means what? Current is also increasing. Suppose two circuits are there. One is called potential difference 2 volt and another 10 volt. Whichever current is more, which voltage is more, then current is more. So now according to the Ohm's law, Ohm's law, current flowing through a conductor according to Ohm's law, current flowing through a conductor is directly proportional to the potential difference. We already discussed potential difference between two ends of the conductor. Between two ends of the conductor. Current flowing through a conductor is directly proportional to the potential difference between two ends of the conductor. So V is proportional to I. Current is flowing through a conductor, V is proportional to I. V is equal to one constant, this constant is equal to Ri. This is a constant, and this constant is called resistance of the conductor. Resistance of the conductor. So this is very important term, resistance. So now our formula is equal to what? V is equal to IR. This is called famous Ohm's law. Okay? So now Ohm's law we are getting. So now circuit diagram is different for the Ohm's law according to the Ohm's law. So now here another one constant term is here. So this constant term is called what? Resistance. So first of all, what is resistance? This is constant. So main electricity term resistance means obstruction of electric charge from one point to another point. We can obstruct the electric charge from one point down to another point in a conductor. This is called resistance. Higher resistance means lower current. Lower resistance means higher current flowing through a conductor. So this is the main reason. So now the circuit diagram for Ohm's law is equal to what? This is the main circuit diagram now we can draw. This is a positive negative potential difference. Current is flowing here, I current flow. So this is what? This is a main term. This is called resistance. This is called resistance. This is a complete diagram of Ohm's law. Earlier is the only for understand. So this is a main diagram for Ohm's law. So Ohm's law, this R is called what? Resistance. So V is called potential difference. Current is flowing here. So V is equal to IR. So this is called what? Famous Ohm's law. So V is equal to IR. So R is equal to what? V by I. We can written like this. R is equal to V by I. So this is called Ohm's law. Okay. So now we can discuss about what is resistance. So V is equal to IR according to Ohm's law. So this is called resistance, R is called resistance, V is potential difference, or I is called current. So R is equal to what? V by I. Now resistance we can call as potential difference. We can written as potential difference by current. Resistance is also called as potential difference by current. So R is equal to V by I. So now SI unit of potential resistance is means volt, ampere, V, ampere A. So volt per ampere is called SI unit of resistance, or which is called as ohm. Ohm, our symbolic representation is called omega. Symbolic representation is called omega. So now SI unit of resistance is called what? Ohm or volt per ampere. Basically we are using ohm or resistance. This symbol is called omega. Omega symbol. So, okay. So R is equal to V by R, volt per ampere. So volt per ampere is called what? Another alternative unit of resistance, or ohm is a SI unit of resistance. This is all about resistance, and resistances look like that. This is a fixed resistance. This type of is called fixed resistance. Fixed resistance. Suppose here one is rho square. This is called variable resistance. Resistance. This is all about what? Resistance offered by the body. Okay. So next, our potential difference we call V is equal to, okay. So now some electric cell, how we can represent the electric cell? Some symbolic representation. So first of all, electric cell we can represent like that. Electric cell represent what? How we can represent electric cell? This is long end is positive, this is negative. Resistance also we can represent. Resistance we can represent what? This is a resistance. Number 3, plug or key. How we can represent plug or key? This is a plug or key. Suppose this is open or closed. This is open. Number 4, plug or key. We can close. If we close the plug or key, how can we represent? This is dot. This is a close, open or clear. The next one, fifth one. What? Suppose electric bulb. Electric bulb we can represent like that. Electric bulb like that. So next one, sixth one. Resistance okay, variable resistance okay. Next, emitter. Emitter means what? So one thing, emitter means what? Emitter one kind of device which can measure the electric current. So we can represent electric current I. How we can measure the electric current with the help of one kind of device. So this device is called emitter. Emitter we can represent like that. A, this is positive terminal, this is negative terminal. And another seventh one is called voltmeter. Voltmeter you can call as voltmeter means what? This is one kind of device which measure the potential difference between two ends of the conductor or circuit. So like that, voltmeter be positive and negative. These are the what? Circuit component about the electricity. Thank you.